Hello, my name is Khairul Mohamad. My student ID is 104406806. I'll be presenting our material selection assignment slides. So firstly, the product and material section. We chose the product carbon fiber reinforced polymer bicycle frame from the Olympic sport cycling road race. Reason is that cycling is a prominent Olympic sport where equipment performance is critical. The bicycle frame is a main structural component and its material greatly impacts weight, stiffness, durability, and aerodynamics. Carbon fiber composites are widely used for high performance Olympic bikes due to their exceptional strength to weight ratio and stiffness. So the product description and its application: the bicycle frame transfers pedaling forces to the wheels and serves as main structural support for the rider and other parts. Olympic cycling frames need to be incredibly light to maximize acceleration and speed while still being strong enough to transfer power effectively with the flex. Another important factor in lowering drag is aerodynamics. Cycling has been transformed by carbon fiber composite frames because they perform better than conventional metal frames. There are several key properties which are high strength to weight ratio to minimize frame weight while maintaining structural integrity. Stiffness, modulus of elasticity, ensures efficient power transfer and handling precision. Fatigue resistance, frames endure repetitive loading cycles. The material must resist fatigue failure. Corrosion resistance, the exposure to sweat, weather, and road debris requires corrosion resistant materials. The manufacturability and cost, which is of fabrication and cost effectiveness for production and maintenance. There are three candidate materials for comparison. The first is titanium grade 5 alloy, which maintains good hardness and ductility while exhibiting strength that is around 40% greater than typical titanium alloys. It has substantial weight reduction benefits due to its reduced density. It exhibits exceptional stability in a range of challenging conditions, showcasing exceptional resistance to several chemicals and corrosive substances. They are also resistant to fatigue failure and exhibits stable performance under cyclic stress. Second, CFRP, which is lightweight, which requires fewer personnel to transport and finish the job, making it an affordable choice. It also has a high fatigue resistance and it's flexible. The flexible carbon fibers break far less frequently. The tensile strength is higher than steel and aluminum, which indicates it can withstand greater pressure and it can withstand worse weather factors, including humidity, rain, radiation, and exposure to chemicals. Lastly, aluminum alloy. A layer of oxide skin forms to shield the aluminum surface from severe oxidation. It also has exceptional electrical and thermal conductivity. Aluminum heat exchangers are employed in food, chemical, and aviation industries. Customer conductivity is related to transfer from one medium to another. The tensile strength of commercial use pure aluminum is 90 megapascal, which makes it an excellent choice for structural materials. Lastly, aluminum can be pulled into wires without breaking because of its malleability, although its ductility is lower than copper. That's all from me. Thank you.
Hello, my name is Fernando Alonso, and I'm going to be talking about the materials comparison table. This table shows a side-by-side comparison of our three candidate materials, which is T6Al4V titanium, aluminum alloy, and carbon fiber reinforced polymer, also known as CFRP. Looking at density, CFRP is the lightest at just 1.6 grams per cubic centimeter, which help reduce the total frame weight, which is a key factor in Olympic cycling. Aluminium is fairly light at 2.78 grams per cubic centimeter, while titanium is the heaviest at 4.43 grams per cubic centimeter. When it comes to tensile strength, CFRP leads again with values between 800 and 1500 megapascal, depending on fiber type. Titanium holds a solid 900 megapascal, and aluminum lags behind at around 470 megapascal. Stiffness, or modulus of elasticity, tells us how well the materials resist bending. CFRP offers a range from 70 to 150 gigapascal. This is because it's anisotrophic, meaning its stiffness depends on fiber direction. Titanium has a high and consistent stiffness at 110 gigapascal, while aluminium is lower at 73 gigapascal. Fatigue resistance is critical for repetitive stress like paddling. Titanium and CFRP perform well, while aluminium shows only moderate fatigue life. In terms of corrosion resistance, both CFRP and titanium resist weather and sweat very well. Aluminium, however, corrodes easily unless it's coated. Finally, in cost, aluminium is the most affordable, and titanium is the most expensive due to its material and machining costs. CFRP falls in between depending on the fiber and processing method used. Next, the justification. Based on this comparison, CFRP clearly stands out as the most suitable material for an Olympic-grade bicycle frame. Its combination of low weight, high strength, and adjustable stiffness makes it ideal for maximizing performance. The anisotropic nature of CFRP allows stiffness to be fine-tuned in specific directions. For example, increasing rigidity in the bottom bracket area to improve power transfer while keeping other areas more compliant for comfort. Titanium, while strong and corrosion resistant, is too heavy and costly for competitive cycling, where every gram counts. On the other hand, aluminium is light and cheap, but it lacks the required stiffness and durability, especially under long-term stress. CFRP also allows for more aerodynamic frame shapes, which directly contributes to reduced drag and faster speeds. While it is more expensive to produce, the performance benefits in elite level racing make a CFRP worth the investment. For these reasons, CFRP is the most justified and practical choice for Olympic bicycle frames.
Hello, my name is Mohamad from Abdullah. So today I'm gonna explaining the sustainability and socio-economic consideration of the chosen materials, along with titanium alloy, 2024 aluminum alloy, and carbon fiber reinforced polymer. For it is for a carbon fiber bicycle frame used in Olympic cycling events. So when choosing materials for an Olympic bicycle frame, it's important to think about the performance and the sustainability. First, the titanium alloy. It is very strong and durable, but it takes a lot of energy to produce and it is expensive. So its production process can impact the environment, and the material is not easy to recycle. However, titanium supports advanced industries and skill jobs. So next is 2024 aluminum alloy is lighter and cheaper than titanium. It is easier to recycle and has a lower carbon footprints, especially with newer green aluminum options. Aluminum recycling helps reduce waste and energy use, making it a more sustainable choice. Finally, is the carbon fiber reinforced polymer. It is the lightest and stiffest material, perfect for high performance bikes. But making CFRP uses a lot of energy, and recycling it is still difficult. Uh, Researchers are working on better ways to recycle carbon fiber to make it more eco-friendly. Uh, but the SFRP's long life and lightweight also help reduce environmental impact over time. So the all of the three materials creates jobs and support technology industries, but balancing cost, performance, and environmental impacts is the key. So right now, CFRP is the best for the Olympic bikes, but improving recycling and sustainability will shape the future of the materials in sports. That's all for me. Thank you.